Okay, so everybody now has, we have 4 stations here, and we have 4 bottles. They already have water filled in them. These are actually going to be tap water samples. So we shouldn't be seeing any bacteria in our tap water, hopefully. So we're all going to be now participating on this next step, on these next series of steps. So we've all come back from the field, we've gotten our samples, and we're ready to plate our Coliscan dishes. So what's the first step? The first step would be to mark your Petri dishes. Again, you're going to need something like a Sharpie marker. I'm demonstrating with a ballpoint pen, but you're going to need a Sharpie marker to write on it. But you're going to have a Petri dish, and the Petri dish has 2 pieces. It has a larger piece that fits over on top of the smaller piece that's a little bit taller, kind of like a clamshell. You want to keep these Petri dishes closed as much as possible. You don't want to open them up too much because any mold or anything can get in there and contaminate the insides of it. But what you want to do first thing is you want to actually flip the Petri dish over upside down. So you want to flip the Petri dish over upside down, and you want to mark it with your marker. And you want to write down some basic information, basically the site number and the number of milliliter samples that you're using on your Petri dish. So generally I'll put down the site number at the top of the Petri dish, on the underside of the Petri dish on one end, and the number of milliliters that we'll be using. Coliscan works by, you can test up to 5 milliliters of sample. If you try to do 6 milliliters or more, the media will not solidify into a gel. So you can only go up to 5 milliliters of sample. Generally, we recommend that you test about 2 or 3 milliliters at a time. That gives you a pretty good range for your bacteria numbers. And you also want to write in small handwriting. If you write in really big letters on your Petri dish, you're more likely to obscure some of the colonies that are growing. And we also recommend that you use like a black Sharpie marker instead of like a purple or blue Sharpie marker, because we're going to be looking for bacteria colonies that are going to be purple and blue in color. Okay? So we've all marked our Petri dishes. And then we turn them back over so they're right side up. And now we have our pipette here. This is an individually wrapped pipette that comes with the kit. And then close your Petri dish. Okay, everything's right side up. Okay. So you can open up your wrapper. There's a little flap here you can peel back. And over by where the squeezy bulb is. And the pipette has 3 parts. It has the tip, a stem, and then the bulb. The only part you want to touch is the bulb. You do not want to touch the stem or the tip of the pipette, because if you do, you can contaminate it with your fingers. If you need to put the pipette back down for whatever reason, you can put it back in its wrapper and you can lay it down and it will still be considered sterile. So, we've opened up our pipette bulb. We're going to take our bottle of our water sample that we're going to be testing for. We want to shake it up. You can shake it back and forth like this, or you can swirl it. It doesn't matter for when you're mixing the sample. And about 5 seconds of shaking is good. And then, if you're really good like me, you can use one hand to open up the bottle, but you may need to use 2 hands. And then what you're going to do is take your pipette bulb, and you want to squeeze the bulb first before you put it in. This particular pipette is a 1 milliliter pipette. You'll notice right below the stem, there's a 1 ml mark. You see that 1 ml mark? It's very small. It's very faint. So today we're going to do 2 milliliters of sample. This is in 1/4 milliliter separations. So you want to squeeze the bulb first, and then you're going to put it in the bottle of your sample. And it's going to be kind of like operation. You want to try to avoid touching the sides of the bottle as best you can. And then slowly release the bulb, and you'll see the water get sucked up in there. And once it gets to that 1 milliliter line, as close as you can get it, retrieve the bulb and then release the bulb and allow it to kind of suck in the water up into the pipette. That will keep you from dribbling your water when you're transferring it to your bottle or your medium. It's a good idea to cap your bottle closed. You can again put your pipette back in its wrapper if you need to lay it down. You do not want to lay down the pipette on the table without being in that wrapper. And then you're going to open up your bottle of your Coliscan. And then you're going to squeeze out all the water you can. Again, kind of like operation, don't touch the inside of the bottle. And squeeze out as much of that water as you possibly can. And once you've done that, put the pipette back in the wrapper and then close up your Coliscan bottle. Now, I did mention that we're going to use 2 milliliters of sample. And this is a 1 milliliter pipette. So we're going to get another 1 milliliter of sample from the same sample bottle. You are allowed to use the same pipette for the same sample bottle. Do not ever use this pipette for another sample because you'll contaminate it. So again, we're going to squeeze the bulb, put it in the bottle of the Coliscan or bottle of the sample, and then release the bulb and suck in the 1 milliliter of water and close the sample bottle. And then open up the bottle of the Coliscan and squeeze out every drop you can into the bottle of Coliscan medium. Okay. So we're actually going to mix it kind of the opposite of the way James Bond likes his martinis. We're going to swirl, not shake. So we're going to swirl it, and about 5 seconds of swirling is good. That's to suspend all the water sample throughout the whole media. And then, once we've done that, we'll put the bottle down, and we're now going to transfer the contents of the bottle into the Petri dish. The recommended way to do this is you first open up your bottle of your Coliscan, and then you're going to take your free hand and you're going to open up the Petri dish, and you want to leave the lid over the bottom of the Petri dish as best you can because that will keep any mold or anything from settling in. Mold creates antibiotics, and that's going to damage the bacteria that is going to be growing. It's going to inhibit the growth. So leave the lid over the top of the bottom of the Petri dish, and then take the bottle, place it between the two, and pour your sample. And you want to shake out as much as you can. Get every single possible drop you possibly can out. Now, I've noticed here that the tables are not level. These are not level tables. And you'll notice that the Coliscan has not evenly applied to the bottom of the Petri dish. What you're allowed to do is you can give it a little bit of a swirl, and that will kind of distribute everything on there. And that looks like we're evenly coated. Pretty even coat. And you want to close the Petri dishes. Petri dishes are closed, good, okay? Now you do not want to disturb these Petri dishes for about 30 minutes to 45 minutes because that's about the amount of time it takes for this liquid to turn into a gel, to a solid. If you disturb it, say 5 minutes from now, what's happening is that we've created an ideal environment where the bacteria are now starting to reproduce. And underneath ideal conditions, bacteria reproduce about once every 20 minutes. So what happens, you'll have one bacteria colony, and then another one will form up next to it. And if they're not disturbed, then their sister bacteria cells will propagate and they'll form 4 bacteria. And then those 4 produce another 4, and so on and so forth. Well, if you are disturbing the plate during this replication process, and the 2 bacteria that are originally like this break off, they start to reproduce like they normally would, but now you're forming 2 separate colonies. And when you're counting the Petri dishes later, you won't know which colony, if they came from the same bacteria or not. They could, if you got 2 colonies close together, it could have come from the same bacteria. That could just happen to have been 2 separate bacteria cells that landed in the medium when you first did the test. So try not to disturb the Petri dishes, except for that initial swirl to get everything kind of evenly distributed. Okay? So this takes about 45 minutes.